is going to, so let's say I want to do for oxygen, the electronic configuration for oxygen. This is 1s2, right? And this is going to be, so I'm having 6 more electrons left. This is going to be 2s2. I'm having 4 more electrons left. This P now can contain as much as 6 electrons. Do you understand what I'm saying? 6 electrons. So that means that whatever is remaining is 4 electrons, and that means I don't need these other ones to get my electronic configuration for oxygen. So there, in today's topic, we are going to be talking about the atomic structure and chemical bonding. So we're going to be learning atomic structure of an element, and we're going to be also looking at the what is chemical bonding. So this video might be divided into several different parts, but in this particular video, I will try as much as possible to delve into what atomic structure is and what are the different things that it pertains as well. So the first thing we're going to be discussing today is what are atoms, and everyone from maybe JS1 or SS1, whatever the case may be, should be able to define what an atom is. And we're always told that an atom is the smallest part of an element that can retain the chemical structure of that particular element. It means that if you have element A, for instance, A, the atom is going to be what is the smallest part that can be fragmented out of that particular element that can give you, still maintain the same chemical structure. So if this is small letter A that can be removed from this capital letter A, it means that this small letter A, which is here now, is called an atom because it can still retain all the chemical properties of this particular element in question. So an atom is the smallest integral part of every element that you can have. So even though we've been told that there are other smaller fragments like your proton, your neutron, let's give you an example. So let's say this is an atom or this is an element. Now in this you can have electrons here, around here, and in this you can also have your proton and your neutron in the nucleus, right? This is the nucleus. How do you spell nucleus now? Nucleus. Now this is the nucleus, this is your proton, and this is your neutron. These two are embedded inside the nucleus. And don't forget, these two are also seen as one of the smallest part of your element, right? Now, don't forget that these electrons are hovering around in orbitals around the nucleus. And don't forget that we're also going to be looking at what the protons are. Proton is positively charged, neutron is neutral, and what? The electron is what? Negatively charged. Right? So these are very important things to take note of. Another thing we're also going to be looking at is the fact that your atomic number, let's look at what electronic configuration is. Electronic configuration is basically an explanation or a way of representing and for you to be able to differentiate all your different elements. So let's say for instance we have let's say for instance the first compound element we have is hydrogen. Hydrogen is H. I believe you can see this part of the board, right? Okay, hydrogen is H. And then your electronic configuration for hydrogen is 1s1. Or if you are using the orbital structure, you are going to be having this instead. You are going to be having your orbital with just 1 electron. Am I correct? So the same thing we have with, let's say hydrogen, helium. Helium is 1s2, and 1s2 is going to be having how many electrons in the orbital? 2 different electrons, right? The same thing with hydrogen, helium, lithium. So I'm just trying to make a point here. You're going to be having 1s2, which is already filled orbital, and you're going to be having 2s1 as well, which is going to be this, and then you're having another orbital where you're going to be having this. So later on in the video or later in subsequent videos, I'll be able to explain to you why or how you have come to achieve this. But one of the major things you must understand, which I'm going to be establishing in this particular video, is this: that there is a template. And one of the reasons why I'm making this video is to help you understand the easy shortcut that you need to be able to use to pass your JAMB. We're not going to be teaching you the basics. We're not going to your SS1 and to break down things for you. This video is going to be trying to simplify and making you get short. Summary part of this is this: the electronic configuration usually always fills in this box. right? So from element, basically in secondary school, you always taught element 1 to 20, right? And then you can go beyond the transition element, metals, and then maybe some other few to the closest 40 or 50. But the major thing I want you to understand is that for this particular box, now the maximum for all s orbital, but now look at the maximums. S orbital cannot contain more than 2 electrons. 2 electrons, right? P orbitals cannot contain more than 6 electrons. Electrons, right? These two major considerations is very, very important for you to understand whenever you are filling this orbital. I'll stop here majorly, but make sure that s orbital cannot contain more than 2 elements, 2 electrons. P orbital cannot contain more than 6 electrons. Once you understand that, it allows you to be able to fill the orbitals properly. So let's go with that. Don't forget that we are not dealing with d orbital until we get here. That's why I'm not giving you that of d. But listen to what I'm trying to say now. So the first thing I'm going to be looking at is this. The s orbital is containing 2 electrons. So if I'm doing for an element, so if you have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. So let's stop here. Now, if you have this is 1 electron, 2 electrons, 3 electrons, 4 electrons, 5, 6, 7, and 8 electrons. Now, the maximum this can contain is going to, so let's say I want to do for oxygen, the electronic configuration for oxygen. This is 1s2, right? And this is going to be, so I'm having 6 more electrons left. This is going to be 2s2. I'm having 4 more electrons left. This P now can contain as much as 6 electrons. Do you understand what I'm saying? 6 electrons. So that means that whatever is remaining is 4 electrons, and that means I don't need these other ones to get my electronic configuration for oxygen. So therefore, oxygen is going to be 1s2, 2s2, and 2p4. Do you understand that? So this is, so once we have this template, 1s, 2s, 2p, 3s, 3p, 4s, 3d. So these ones you will start using them when you are talking about transition table, right? Transition metals rather. So, but the major thing you must understand in the basis of it, writing and the electronic configuration of a particular element is to understand that the s orbital cannot contain more than 2 electrons, the p orbital cannot contain more than 6 electrons. When that is established, you can write as much electronic configuration that you want to write. So let's look at the last. Let's look at what again? Let's look at let me pick an example. Let's see what element. So this is what I want you to do now. Pick an element on the periodic table from 1 to 20. Once you do that, then start filling it. Make sure that, let me put in the maximums for you. For this, for all these things that I have, for this is 2 electrons. Maximum for this is 2 electrons. Maximum for this is 6 electrons. Maximum of this is 2 electrons. Maximum of this is 6 electrons. Maximum of this is what? 2 electrons. So we'll stop there. Do you understand? So all these maximum must be exceeded before you can move to the next one. Do you understand what I'm trying to say? So you must move from 2. So you see that in total, 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 2, 20. You see that this covers your first 20 elements. Do you understand what I'm trying to say? So with this, you can easily and comfortably write your electronic configuration for the first 20 elements without stress. But the first thing you must know is to know what the major template is. 1s, 2s, 2p, 3s, 3p, 4s, 1s, 2s, 2p, 3s, 3p, 4s. Very, very easy to know. In fact, one of the major things I do is SPDF. This SPDF is what makes me to know it easily. 1s can only have is the starting point.